Okay, let's start chapter 9, the circles. Okay, this is another tough chapter, so make sure that you keep up with materials and you don't fall behind, because it's going to be tough to catch up if you fall behind. Okay, we're gonna skip a warm-up. We're gonna look at this in the class. Alright, so we have 7 sections and we are doing all of them. Okay, and for the probably we're gonna do a quiz after 9-4. And in this packet I have these 2 sections together. So we have just 1 packet for this and then another packet. So 3 packets before the quiz. Okay, and there are 5 objectives through these 4 sections. So 3 of them are actually in this packet. Define a circle, a sphere, and terms related to them. Recognize circumscribed and inscribed polygons and circles. Okay, and apply theorems and relate tangents and radii. Radii is the plural of radius. Okay, so here are the terms. Okay, it's a lot to memorize in this chapter, unfortunately. Okay, I wonder if this is focused. Okay, is it better? Alright, a circle is a set of points in a plane that is given distance from a given point in the plane. So there's a given point and then it's the same distance from that point. It's the set of the points that is equal distance from the point will form a circle. Okay, the given distance is called radius. Any segment that joins the center to a point of a circle is called radius. And all radii of a circle are congruent, it's the same length. And rim of the Ferris wheel shown is a circle with a center O and radius of 10. It's an example. A chord is a segment whose endpoints lie on the circle. So the chord is a line that cuts a circle. Okay, and if the chords go through a center of the circle, that is called diameter. Okay, and instead of a segment, if it's a line, it's called secant line. Okay, and like a word radius, the word diameter can be referred to the length of the segment or the segment itself. So when we say diameter, we may be referring to this line, or diameter meaning the length of that line. The same thing for radius. Radius can be referring to this segment or can be referring to the distance. So in a way, for example, if this is O and this is A, when we say radius, it can mean OA, which is the actual segment, or OA, which is the distance. Okay, it refers to both. The tangent is a line, well, we talked about this briefly, of a plane, a circle that intersects the circle exactly at one point A in this case. And this point is called point of tangency. The tangent ray PA here and the tangent segment PA are often called tangents. This tangent could be just segment or could be a line. And AP is the tangent to circle center O, and circle O is tangent to the line AP. A is the point of tangency. Those are the words that you need to know. So far, I think, other than the chord and the secant, you already know these terms. Okay? Sphere with a center O and radius R is the set of all points in a space at a radius R from a point O. So if the circle was the correction of the equal distance from a point on the plane. Now this can go up and sideways and downwards, and then if you collect all those equal distance points in the space, you get a sphere. Okay, so the radius in the sphere is always congruent. Okay, and many of the terms used in the spheres are the same as those used in circles. So OA, OB, and OD are radii. BD is a diameter because it's a chord that goes through a center. BC is a chord. Right here, the segment BC is a chord. And if it's a line, it's a secant. Okay, the chord is a segment, secant is a line. Okay, that's the difference. AT is a tangent, and AT is the tangent segment. Okay. Congruent circles or spheres are the circles that have a congruent radii. Okay, the circles, as long as the radius is congruent, then the circles are congruent. Okay. Concentric circles are the circles that lie in the same plane and have the same center. So this is concentric circle. Okay, so in a way, this is like similar circles with a well, the circles are all similar. Yeah. Rings of the target illustration is concentric circles. All right. Polygon is inscribed in the circle when it's like this, and the circumscribed, and then the circle is circumscribed outside the polygon. So this is inscribed polygon, circumscribed circles. Inscribed polygons, circumscribed circles. So if I have a circle and polygon is outside, this is inscribed circle and circumscribed polygon. Okay, well, here's a circle and here is a triangle. So it's these are touching. Okay, it doesn't cross, it touches. Circumscribed and inscribed means touches, it doesn't cross. Okay, so in this case, these are all tangents. Okay, this is a circumscribed polygon, inscribed circle, and this is the opposite. Okay, for each exercise, draw circle O with radius 12, then draw radii OA and OB to form an angle with the measure named. Find the length of AB. Okay, so you draw a circle, and then you make a degree, and you draw, so this is A and O, B, O, and you have to find this length. Okay, and radius is 12, so that's 12, and if it's 180, this is what it is. So now actually the diameter is AB. For 60 degree, you do this one, right? You get the actual length. The same thing for 60 degrees. Okay, this is 12, B. You want to find out this length. Okay, this is 12 and 12. And this is 60. This is 90. This is homework. And for 120 as well. Okay, so something like that. This is 12. This is AB. Okay, so I drew the diagram for you. You get the numbers. Okay. Alright, it's continuing. This is a long packet actually. Yeah, there are two more pages of instruction, and then the rest is exercise. Okay. Q and R are congruent circles, so that means radius are the same, and intersect the C and D, and segment CD is called common chord. Okay, so if I draw a line here, that's a chord for this circle, but it's also a chord for this circle, and that's a common chord. And what kind of quadrilateral is QDRC? So it's this. What kind is it? Homework. CD must be perpendicular bisector of QR. Why? Okay, homework. If QC is 17 and QR is 30, find CD. Okay, these are good problems. Think the right triangles and the quad section. It's kind of similar things that we've done. Should be able to do this. Okay. Draw a two congruent circles with radius 6 each, passing through a center of the other. Find the lengths of the common chord. Okay. So here is a circle. Okay. And the other circle is gonna go through the center of each other. Okay. And then you want to find out this length. And you also know the radius is 6. Okay, how do we do this? Draw two congruent circles with radius 6. Okay, and find the length of common chord. So this. So if you draw this line here, this is the, look at this circle, okay? This is radius, right? This is radius of this circle, center from here to end, and it's also radius of this circle from center to the end. And this is also radius, and this is also radius, right? Maybe some people are not saying it, but if this line is a collection of all the radius, right? The same lengths. So this have to be radius, this have to be radius for this circle. And from this center on this circle, this have to be radius, and this have to be radius. So it's all same lengths. So this should be all 6. So this is equilateral triangle. So when you say equilateral triangle, you should be thinking about special right triangle, because this is 60 degrees. So if this is 6, this is 3, and this is 3 root 3. And there are 2 of these, so 3 root 3 plus 3 root 3 is 6 root 3. This is a tough one. Okay. Tangent related to, theorems related to tangent. Okay. If the line is a tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. I feel like you learned this, but if it's a tangent from the radius, it's always 90 degrees, because that's the shortest distance. Okay, and there's a proof, but we don't have to make a proof. Just to know that when it's a tangent, then you know that this is 90 degrees, which is very handy to know, because if the problem says the line is a tangent, you know that this is 90 degrees, which you can use for many different things. Okay, and here's a corollary. Tangent to a circle from a point are congruent. Okay, so from this means the PA equal PD. Whenever there is a point and you draw a tangent to a circle, these are congruent. So if I draw another point over here, for example, and draw a tangent here and tangent here, like that, then these are also congruent. Okay, you will see in the problem how to use this. And the reason is because if we draw this, you can make this by HL, because this is 90 degrees, right, by the theorem, and the radius are congruent, and that's a leg, and the hypotenuse is shared, so HL. So that means these are corresponding sides of CPCTC. Yeah. All right. And converse of 9-1. 9-1 is the tangent one. Okay. So the converse is, if the line is perpendicular to the center, then it is a tangent. Okay. If a line on the plane of a circle is perpendicular to the radius at the outer end point, then the line is a tangent of the circle. Okay. So even though the problem doesn't tell you the line is tangent, if they tell you that it's 90 degrees, or there's a mark in the diagram that it's 90 degrees, then it is a tangent. Okay, and when each side of a polygon is tangent to a circle, the polygon is said to be circumscribed about the circle, and circles inscribed in the polygon. I drew something like this in the other page, but yeah, so this is a tangent. Okay, but so going back to this right here, if you look at it, this is the point and these are tangents. So these are congruent. These are congruent and these are congruent. How cool is that? Okay, and these are all congruent. These two are congruent. These two are congruent, and these two are congruent. Okay, because those are tangents from a point. Okay, and here are more term to learn. A line that is tangent to each of two coplanar circles are called common tangent. A common internal tangent intersects the segments joining the circle. That's common internal tangent. Common external tangent. The common tangent touching external, internal. Line AB is a common internal tangent. Can you find another one that has not been drawn? So that's this one, right? And the other one is over here. Okay. A circle can be tangent to a line, but it can also be tangent to another circle. Tangent circles are coplanar circles that are tangent to the same line at the same time. Okay, so circle A and circle B are externally tangent because it's touching at this tangent line. And circle C and circle D are internally tangent because one triangle and one circle is inside the other circle. Okay, and if you see in the construction site where the pipe are stuck up like this, these are all tangent circles. Okay, all right, and the rest are exercise. So we will do most of this in the class. Okay, we are done.